All right, hello B5 Secondary 3 class. I'm making you take notes on a few things today, so please open up your notes to this page. It is page 12. We're going to spend 2 days on this concept. The concept is solving rational equations, but we need to make some headway while I have a sub today, so you're going to take notes while I'm gone from this video. You'll notice that you also have 2 Math Excel assignments today. You've got 3-5 solving rational equations, the easier ones, and 3-6 solving rational equations, the harder one. We'll talk about more of the harder ones in class on Tuesday. You'll notice that this one's not due until the 15th, but I did assign both of them today so you can start working on them if you want to. You'll notice there's also an extra credit assignment on Math Excel you can start working on if you want to. So, notes, page 12. Everybody get that out and get ready. Okay, so what is the domain and range of a function? When we talk about domain and range, remember we had 3 over x. The x cannot be equal to 0. So the domain of a function fails whenever the denominator is 0. So if you have something like x plus 3 over x squared minus 25, it doesn't matter what's in the numerator, but your denominator will factor to x minus 5x plus 5. So your domain is all real numbers except x cannot be a 5 and a negative 5. Hopefully you remember how to do that. Why do we care about the domain? Because denominators cannot equal 0. If a denominator equals 0, you get a fraction that is undefined. Okay? So again, let's go ahead and practice these few. Find the domain of each function. So number 1, x plus 5 is the denominator. It doesn't matter at all what's in the numerator. We just need to worry about the denominator. So x plus 5 cannot equal 0. What number for x would make that denominator equal 0? It's when x is a negative 5. So our domain is that x cannot be negative 5. Sometimes you'll see this in set notation. It has a curly bracket, x, and then a vertical line. That just means x such that x cannot be negative 5. Okay, I'm going to have the sub pause the movie right here. I want you guys to try number 2, 3, and 4. I'll give you about a minute. The sub can give you about a minute, and then I want you to check your answers with the video. Okay, so when you've unpaused, go ahead and factor this one, x minus 5, x plus 5. So your domain is x cannot be positive 5 or negative 5. Number 3 is an odd one. X squared plus 6 is equal to 0. Remember, if you solved this one, you'd get a negative 6. When you square root both sides, you end up with an imaginary number. So if x cannot be an imaginary number, and that's the only problem with the domain, that means your domain for this problem is actually all real numbers. There are no x's that will make that one be a 0. And then the last one is just x cannot be 0. Okay, so solving. Okay, so the next step, what is the difference between an expression and an equation? So today we're going to start solving equations. Everything we've done so far in this unit has only been expressions. So if I give you 3 over x plus 4, that's an expression. If I put an equal sign and another rational next to that, I now have an equation. So if I said 3 over x plus 4 plus 5 over x squared equals 10, I now have an equation. What's the difference? An expression can only be simplified. An equation can actually be solved. So we could take this problem and actually figure out what x is if we wanted to. Next line says, why is it important to check your answers? You must check your answers in this type of problem because let's say this right here was our equation that we solved. And let's assume for a minute that the answers we got were x could equal 5 or negative 4. Well, we come over here to our original problem and we say, uh-oh, we have a problem right here. The domain for the rationals in this equation are x cannot be a negative 4 or 0. If one of our answers was -4, then that's not going to work in our original equation, so we call that an extraneous solution. What that means is that -4 cannot actually be an answer, and your only answer would be x equals 5. Now, where did I get 5 and -4? I just made those up for this example. We'll go ahead and start solving these in just a minute. Okay, turn to the next page. How do you solve a rational equation? First, you undo all the division. To do this, you find a least common multiple or a common denominator, and you multiply every term by that common denominator. Cancel common factors because they equal 1, and then you're going to either solve with a linear equation, just get x by itself, or you'll have a quadratic equation where you need to use your quadratic skills. How do you solve a quadratic? You factor, you square root both sides, or you use the quadratic formula. And then step 5, I think that should actually be a 3. Step 3 is that you check for extraneous solutions. That means that you need to make sure that your answers actually work with the denominators of your original problem, and if you have an answer that doesn't work, then you can't use that as an answer. You call it extraneous. So let's try these simple ones. Oh, there's the bell.